Okay, pause the video and write this down. Okay, so asymptotes are an important feature of many graphs. So vertical asymptote is when your function shoots up to infinity or down to minus infinity. Okay, you may want to notice here that limit x goes to 2 plus of 1 over x minus 2 is plus infinity. And the horizontal asymptote is where, well, it's a different kind of limit here. You go limit x goes to infinity of 1 over x plus 3. This is going to give me the 3 here. Okay, so if we have a function that we want to graph, we're going to do limits to find horizontal asymptotes. So let's just see here. Find the vertical asymptotes and or horizontal asymptotes of, let's come up with a function here. F of x is, say, 2x squared plus 1, and then say x squared minus 1. Okay, so to find vertical asymptotes, okay, the short answer is to just look at that denominator and find out, when is it 0? Okay, it's the division by 0 that almost always is going to cause our vertical asymptote. And here we get x is plus or minus 1. For horizontal asymptotes, well, we're going to have to do two limits. One as x goes to infinity, and another one as x goes to minus infinity. Because if you think about it, when I go to x goes to infinity, what I'm asking is, what's happening to my graph when I go way to the right on my xy plane? And then for x goes to minus infinity, okay, what I'm asking with this limit is what's happening to my graph when I go way to the left? Okay, am I approaching? So if you look at this example up here, you can see my function here is approaching. See how it's approaching the horizontal line, y is equal to 3. So we would like to know if that's happening. So that's a horizontal asymptote. Okay, so I forgot to say an asymptote, in general, an asymptote is a straight line that a function is approaching. Okay, it could be vertical, could be horizontal, and there's even what's called slant asymptotes or skew asymptotes, but we don't cover those in this class. All right, so back to this horizontal asymptote example. I do a limit. Okay, at this stage in the course, I'm going to allow you to just say to yourself, okay, this one here doesn't matter, and this minus 1 here does not matter when x is very large, so we just get 2 here. And for minus infinity, same logic applies. So the horizontal asymptote is y is equal to 2. And it happens twice. Okay, so when I go way to the right, my function is approaching y equals 2. And also when I go way to the left, my function is approaching y equals 2. So I don't know. Let's see. What does this look like? Very roughly. Okay, so when I go way to the left, I'm approaching this x equals 2. And also when I go way to the right. So let's see. Now I'm just, so my function, I'm not sure what it's going to look like, but maybe it'll go like, it may go like this, or it's possible it'll go like this. So how can I figure that out? Well, I can say that, well, it's a bit tricky. I could probably just do test values at this point, just plug in test values here to see if I'm bigger or smaller than 2. If I'm bigger than 2, then I'm going to have something like this. And if I'm smaller than 2, then I would have something like this. And if I plugged in like minus, say 6, if I got something less than 2, then I would say my function is doing that. And if I got something bigger than 2, I'd say my function is doing something like that. Okay, so to recap, okay, typically for vertical asymptotes, you take your denominator, set it equal to 0. And then for horizontal asymptotes, you calculate these two limits. In this case, I got 2. I got the same thing for both of them, but that need not be the case.